Probably the thing is that going to do is just to recap what I have learned during my courses in Cisco networking and this economy. Some based on okay, so this CMP. Okay, first to what we have in this in start of it like these are the main topic. All right. As we can see, we have ICMP messages explaining how ICMP is used to test network connectivity and ping and trace route setting testing. Okay, we can have this. As is available for both and messaging protocol, same services, but includes additional functionality. They include a host reachability, destination of service, unreachable, and time exceeded. Okay, we have host reachability, which is ICMP echo message can be used to test the reachability. Sends echo request to a host, post response with an echo reply, claim button. Okay. Basis of the ping utility. We have some destination or service unreachable. We have net unreachable, which is CMP before those things. They have net unreachable, host unreachable, port protocol unreachable, and port unreachable. We have no route to destination. It's administratively prohibited beyond scope. Address unreachable and port unreachable. Okay. There are types of unreachable codes. We have time exceeded, which is cannot be forwarded because the time to live of the packet was decremented to 0. Absolutely good things to do because sometimes when we forward things, but it will be like in infinite cycles. So with this, it will be help us to organize our database better. Transport better, yeah. Receive. This is car, okay? And what we call the time exceeded. Let's start. Use the hop IP6. We'll use the hop limit. And this the different things. All right. Next one, I see IPv6 messages similar to the control and error messages implemented by SE IPv4 are encapsulated in CMPv6, and we have router solicitation and router advertisement message, duplicate detection and address resolution. We have neighbor solicitation and neighbor advertisement, redirect message. Okay. Router, we have router resolution solicitation. Okay. Or router advertisement. Okay, so router we send their advertisement like all this or you use Slack or prefix it as your default gateway. Okay, so it will advertise itself to all of the enabled IPv6 devices, right? And then the IPv6 will send back reply with so the devices will come first, and then we will like send the router will send back with an advertisement message, right? That's the thing. See your goal. I don't believe in failure. Once I was 11 years old, my father have told me, "Go make yourself a friend so you will be lonely." Once I was 7 years old. Big word, and then you seem bigger. Okay, so next we have an S message with neighbor solicitation. Say that is assign a global IPv6 unicast or a local link. Okay. Duplicate address detection. Happy birthday to you. Respond in message. Okay, so PC1 send and so again send a solicitation message. And to ask who has this IPv6 address and then send him the MAC address. Then we have this to determine the MAC address. The device will send an SMS message. Message will include a targeted IPv6 address, and then the device, the targeted IPv6 address will respond with the NA message. Okay, that's it. The ping and trace route test will have ping is okay. Use ICMP echo request and echo reply messages to test connectivity between hosts. All right. Heart, don't speak. To test connectivity, it's the ping command. It's received feedback on the request. It's not received time out value. Ping provides message a response was not received. Okay. That's what this ping do. Perform before sending the ICMP echo request. They'll call back the default gateway and the remote store. Okay, used to test internal configuration before being the loopback address of 2.127.0.0.1 installed on the host, properly configured. Alright, ping can also be used to test the ability of a host to communicate on the local network, being the IP address of the default gateway of the host. A successful ping to the default gateway indicates the host and the router interface serving as the default gateway are both operational on the local network. So if it's working, but we cannot really access to the web, like so. There's a problem is like DNS used because the router is normally up is operational. Okay. The address does not respond. A ping can be sent to the IP address of another host or local network that is known to be operational. So if either the phone gateway or another host respond, then the local host can successfully communicate over the local network. That's it. So the respond the holders. So the problem with the router interface serving as the default gateway if it works with another if our local but not really with another host. Wrong default gateway address has been configured on a host. Okay, that's the problem with the default gateway. Sending ICMP echo request and then the default sends echo reply confirming connectivity. Ping a remote host. Ability of a local host to communicate or internet network. Solo being an operational IPv4 host and remote network. IP routing to forward packets. Successful. Verified. Confirms communication local network. Operation of the router is serving as the default gateway in the operation of all other routers that might be in the path to the local network, the network of the remote host. Limit or prohibit the entry of ICMPs into the corporate network. Therefore, the lack of a ping response could be due to security restrictions. limits the entry of ICMP messages into the corporate network. So therefore, lack of ping response can be due to security restrictions. Okay, with the trace route, it will test the path, list of hops that were successfully reached along the path. Okay, verification and troubleshooting information. All right. If data reaches the destination, then trace the interface of every route and the path between the hosts. Data fails at some hop along the way. The dead trace of the last route that responded to the trace can provide an indication of where the problem or security restrictions are found. Round trip time I'm using fails to respond. It takes to reach the most remote host. And host to return asterisk in the case the lost or unreplied packet can be a problem. Okay, router in the path may indicate the router is not configured not to reply. Is configured not to reply. IPv4 TCO time to live and the hop limit. Time to live. Okay, the hop limit layer had three headers. ICMP type exceeded message. Sequence is where TTL field value 1 and this calls the TTL. Okay. Driven had the address of the first hop. Implement increments the TTL field for each sequence of messages. There is as the packet is timed out further down the path. Reached until the destination is stretched or is incremented to a predefined maximum. The host one with either an ICMP port, unreachable message, or an ICMP echo reply message instead of the ICMP time exceeded message. So reachable message or an ICMP. Okay, after the whole respond with either an ICMP port, unreachable message or an ICMP echo reply instead of the ICMP time exceeded. So the final destination is reached. So ICMP port unreachable. Okay. Test and restore the okay. This is like summary. AutoIP is only best effort protocol. This provides for error messages and informational messages when communicating with another IP device. Messaging protocol for IPv4, same services for IPv6. Additional functionality used to test the reachability of a host or IP network. Okay, so let me just summary this one. We use as the reachability of the host on IP network. right. An IPC mechanism used to test the reachability. Okay. Respond with an echo reply and reduce the source. Okay. Packet increments the detail viewed in the IP. The discard packet and sends a time exceeded message. If the router cannot forward the MPC because the packet had expired. Show error. Okay. Part of the ND or NDP, RSRA, and SNNA use the ping command to another host on the network, receives the echo request, respond echo reply as which receiving feedback on the time until the request was sent. When the reply was received, measure of network performance. Timeout value was not received, being the remote host, local loopback, default gateway, and remote host. Generate a list of hops that were successfully reached along the path. Troubleshoot the information. Vary router in the way to the trace can prevent the problem. Security restrictions are found. Packet text to reach the remote host and for the response from the host to return. Router is a templated text to reach the remote host and for the response from the host to return. Okay, and that's it. Next, I will go to the next chapter, which is routing. All right. Okay, routing. So routing in the network layer. I have this one, which is how to host route as routing tables. To host routes. Okay, we have both. Packets always created a source so that must be able to redirect packet to the destination. To do this, host and devices create our routing table is to direct packets between them. So that is another role of the network layer is to direct the packets between them. A host can send packet to following itself, which is referred to as the loopback interface. TCP/IP protocol stack on the host. On the local host is on the same local network. The source and the destination share the same network address. Remote network do not share the same network address. Okay, so host forwarding decision. The source and device determine whether the destination IP address is on the same network that the source device is on. Varies by IP version. In IPv4, the source device uses all subnet mask along with its IPv4 address and destination IPv4 address to make this determination. And the local router advertises the local network address prefix to all devices in the network. Or so just in IPv6, advertise to all devices on the network. Users with IPv4 it use its own subnet mask with its own IPv4 address and the destination. Oh, like all of that. In a home or business network, you may have several wired and wireless devices interconnect together using intermediary devices such as a switch or a web. Localhost or local network sending packet to the device configured to semi network as home device. forwarded out of the host interface to the destination device directly. Of course, we want our devices to be able to connect beyond the local network segments such as out to other homes, businesses, and the internet. Sends packet to a remote destination device. Okay, so routing is the process of identifying the best path to the destination. The local network segment is referred to as the default gateway. Okay, so this is network device that can route traffic to other networks, which is analogy that network is like a room, then the default is like a doorway. Network you need to find a doorway. Network default features it has local IP address in the same address range as other hosts on a local network. Data into the local network forward out of the local network and it routes traffic to other networks. Required to send traffic outside of the local network and cannot be forwarded if there is no default gateway. The default gateway address is not configured or is down. A host routing table will typically include a default gateway IPv4 either dynamically from the HCP configured manually. The tasks or the host can be configured manually. This is to configure with IPv4 address as the default gateway. Configure creates a default route in the routing table of the PC. The default route is the route of pathway your computer will take when it tries to connect to a remote network. Default to so okay, so that is the default gateway. Host routing tables. Not too much on Windows. Maybe I will do this faster. Interface list, media access control MAC, IPv4 route table, and IPv6 route table. Routing tables. Okay, the main part. The router examines the destination and interest of packets. Routing table. Okay. All non-network addresses and where to forward a packet. Routing entries or routes. Route forward a packet. Okay. Matching route entry. Next hop or exit interface. The encapsulator examines this, such as the best match. Next, we have the IP router routing table. Directly connected. It's configured with IP address and is activated. Different network segment, remote networks, other routers, default route. Okay, we have this. This is called like the directly connected network. The direct in the router one IPv4 table would be this one for router one. So this one, which is called as the directly connected networks. The remote network would be this remote. So as we can see, with the R2 directly connected is this because it's connected to this one switch, this one like router, and this is gonna be for the remote network. Manually entered in the route using static routes and dynamically unlearn automatically using a dynamic routing protocol. Static routing. Route entries are manually configured. So we have IP route 10110, the sender mask to 205, 209.165, 200.226. Remote network address, IP address of next hop router to the require new static route. What does that mean? Um, okay, change network topology, so this should be manually reconfigured. All right. It's more effective when there are few redundant links. 18. Okay, that is static routing and dynamic routing. Learn about the remote networks, default role or other roles, routers, compensate for any topology changes without involve network administrator. To know about the okay, it remote network and the way are to using the routing protocol SPF to let our know about the IP address of the router 2. Introduction to IPv4 routing table. We have common route source code include L for directly connected local interface IP address, C with directly connected network, S for static route. O for SPF, D for EIGRP, and S for static route. See now. The interface used to reach the network. The slide is kind of blurred for me to read. Routing at the network layer summary. Okay, so this is kind of a summary. Okay, so on Windows host, we can use the RAM to print or -R. Kinda all of the things. This module, and then just to summarize it. Directly connected networks monitors on default route, which is dynamic routing protocol. So telnet, FOSPF and AIGRP. manually configured, privileged exec mode, Cisco RS router. Okay, and that's it for this chapter. All right, next. Oh, I will go on to the next chapter. There are still five. Oh, this guy's sleepy, but it's okay. Yes, only five left. It's gonna be okay. All right, we have I, only GUI static configuration and addressing types of IPv6. We have unicast, multicast, and anycast. Uniquely identifies interface enabled device. Single to multiple and anycast. Any unicast can be assigned. Nearest device having an address. IPv4 have broadcast, but IPv6 is not. Essentially gives the result. Oh no, something gives the same result. Prefix length, network portion, dotted decimal subnet. All right. It's only called the prefix length. It's not use dotted decimal subnet notation. Its slash notation is used to indicate network portion IPv6 address. Range from 0 to 128. /64. Alright, we have prefixes for interface ID for 64. Stateless address auto configuration. Stateless address auto configuration to create and manage. Okay. Type of IPv6 unicast address. Oh, there are like too much slides. I propose so. Unicast interface on IPs. We have GUA, global unicast, globally unique internet routable addresses, statically or assigned dynamically linked local addresses. Every IP's enabled device on the same local link, and a global we will globally, and link local is local, it's global. Okay, that's it. Subnet. A single link, unique must only be confirmed on the link that not routable beyond link. Unique local address. FCOO, FCOO dot slash 7 FDFF. Okay. Used for local addressing within a site or between a limited number of sites. Need to access another network. IPv6 global unicast addresses. I cannot block the RIRs or one or two or the semicolon colon slash three are being assigned. If or one and then all one is called at 3FFF or 2000. All right, I understand this. So it's gonna be like the binary of the hexadecimal. This 1/8 of the total PVC address space. Small portion of the types of unicast and multicast. Documentation purposes. Examples. All right. 3FF /40 global routing and /64 for prefix. We have subnet ADI. GUA. GUA is 2001. Double colon mean the rest of the address is contain all zero. All right. The size of subnet ID. /32 global routing prefix. We'll have 4.3 million subnets, 18 quintillion devices per subnet. Oh, that's a large number. Enterprise network, different parts of the address. Portion address with a 4-hex stack indicating the subnet ID, interface ID. Interface ID, host portion of an IPv4 address. the equivalent to a host. Having one or more IPv6 address should be used to retrieve the 64-bit interface ID when eating hops per subnet. Allow the stateless auto configuration address. Address auto configuration. O1 and O0 assigned to the device can be used because the broadcast addresses are not used within IPv6. Thus, it is reserved as a subnet router. Any cache address should be assigned only to routers. Local link on the same link or only on that link. Must have an LOA. It's all without communicating with a DHCP server. Oh, okay. So 1111111010. 200 from 201. Enable users to send routing updates when the host use the as the default gateway. Statically and dynamically manually configured. Additional bits. You have static GUI configuration. have a link local. So maybe this is all for each chapter. You read this. The thing on this like to give us presentation about IPv6 like unicast, multicast, and anycast. Unicast is gonna be like the router interface. Multicast one to many, and anycast like one to any, to nearest, something like that. And we have the GUNLA, which is global unique and local link address. Routable, okay. Routing prefix as subnet and the interface. Most are the routing prefix is 64 and interface 64 with global routing. There could be 16 and 80, 32 with a subnet ID. Local link never are on the same link, only on that link, either statically or dynamically, is IPv6 address and their prefix length. And that's it. All right. Next, 35. Switches. Okay, the only thing we need to know about is gonna be the switch and the routers. Alright, we have Cisco switches. Home and small businesses usually don't require more one or two networking devices to function efficiently. Peace and business enterprise sufficient connectivity for the average small group of users. GUI guides you through the most common configuration items. Future records on, tell me what's going on. Flow data across the network. Data traffic forwarded based on information not available at lower layers. Large switch can filter the data and send only all the port is connected to the destination based on MAC address. Simpler. And one special things to recommend is LS switches will something within less the organization. Interconnect local networks are needed in a wide, the wide area network environment. Understanding what and routers used to connect multiple networks to each other. Alright, so switches on like the local and the routers like more global. Yeah. IP phones to share broadband connectivity. Okay. Cisco LAN with switches. We have type ports. Of all devices that need to attach to the wired network. So probably there's 36, 38, and 39, and I will not really go to the 39 and 38. Maybe this one will be to once later myself. Probably I will go only through maybe like because I have learned it kind of properly. 36 and 38 and 39, so stressed. Not really. Alright. Tab parts. So Thirsty from this. Okay. Small and medium-sized networks. 24 1 Gbps data ports with PoE powered from the switch to model 40 gigabit per second. System status. And so on. Okay. Maybe we have routers. We have operating system, CPU, central processing unit, random access memory, read-only memory. Cisco routers require CPU. Accept operating system instructions and just system initialization. The routing functions, switching function also. We have console ports to LAN interfaces, network interface modules, which is NAM. We have RJ45 port, USB Type B, two interfaces. UC port management interface, auxiliary port, file transfer, remote management access when to gigabit internet. used in networks today. Okay, that's it. Store and forward switching or cut through switching. No, not really. We don't do this. We have only learned about this. The troubleshoot would be something really much. So the thing is, I'm gonna look through this only. Like there are lots of things I would read, would learn this morning, which is like the summary based basic knowledge only. I think so. Bottom up, top down, follow the path, substitution, comparison, educated guess. Educators get is like I would say that if you what we have learned here, like when we can ping the on the network but not that page, sure it could be like DNS problems, or we can ping our local network but not from our the remote. It could be the IP, the default gateway configuration. So it's like we can ping our is educated guess. Bottom up is like we from the physical layer to the application layer. Like in the OS and model, there are seven layers. Bottom up will be go from step to step. Also, with the top down is from the upper layer to a lower layer. But it takes time and follow the path. So we will pick one layer like choosing like personally choose layer two, and if it's check if it's work or not. So if it is working directly, so also layer one is correct, layer two is correct like this, and then so the problem is maybe must be on the upper layer. Also a substitution, just like get a substitution with we want to check if layer three is working. Put in layer three. If it works, it works. If not, it's a problem. It's not a problem. It's, yeah, that's it. That is about a layer. Substitution comparison is the same thing, but like we use the same, but some of them have some small differences to identify where is exactly the problem is. That's it. Okay, we have to we have to check to select one of the troubleshooting method. Proper power supply. If the wireless client is unable to connect to the AP because of the wireless connectivity problems, incompatible wireless with internet when conversation occurring on overlapping channels, the strength of an RF signal decreasing distance among other, or radio frequency. Use SSID authentication and encryption. Monitor. Yeah, check the IFP configuration for the client. Nhưng biết sao phải hố đêm Hurricane là mặt nhớ tên mặt đêm nhớ nhem Calling people name baby. So the problem is that I will it's kind of the most a lot of things to learn from this. I will just look through this once and try to look at it later because troubleshooting is like really a thing that we should able to understand directly, not can learn like. All right, it may be like once later. Troubleshoot, because troubleshoot is really essential. The problem is like I can be off this and taking this to tomorrow because it's not too much things. Anyway, thank you so much for being here.